So I'll go to my handy dandy Google do-ticker, and we'll just type in LBJ versus Shaq. See if I can pull it up that way. Z-score. Let me do Z-score. I think we're talking about a basketball game. LBJ versus Shaq. Z-score. There we go. There is the example that I'd like to use. I want you to write it down. And there's a reason. Thought I could blow it up. There we go. Oops, it's too much. And you don't have to write it word for word. Just write it to where you know what you're talking about. If that makes sense. Usually I just pull it out of the book. This is the first time I've actually pulled it off of looks like somebody's test or worksheet. But that's it. It says with a height of 75 inches, LBJ was the tallest president in past century. With a height of 85 inches, Shaquille O'Neal is the tallest player on the Miami Heat basketball team. And this was done at that time. In other words, it was evidently, this is when he was, when they wrote the 10th edition of the book, that's when he was on the Miami Heat basketball team. Some of you Sports Center 24 hours a day watching people can tell me when that was, but I don't really care. And he says, Lyndon Johnson, among the presidents in the past century, who is relatively taller. Now notice that they have relatively in italics. Any redneck could tell you that Shaq is taller than LBJ, right? But that's not what the question is asking. The question is asking who is relatively taller. Now, what does that mean? Yes, among their group of people, who is taller? You got to think about that a minute. What's the requirements for being president of the United States? You got to be at least 35, or you got to be a certain age. I forgot. Is it 35? What else? Yeah, U.S. citizen. Sorry, I had something in your throat. What else? Nothing.
You'd say something you should have, but
I'm going to keep my mouth shut too. All right, two requirements. What about how tall you are? So technically, a midget could be president of the United States. Yeah. Somebody in a wheelchair could be president of the United States. Were they? Yep. Who? FDR. All right. So let me ask you a question. If a person is tall, if a person that has served as president is tall, then they're pretty much a big fish in a what? Little pond. Why? Because there's no requirement, height requirement, to be president of the United States. So you can have some 3 foot, you can have some 8 foot, 4 foot, you can have some 6 foot, you can have some 6'5". What's the requirement for being in the NBA? Height is not a requirement. It's a what? Advantage. So most people, if you're 6 foot and in the 2nd grade, who's going to be knocking on the classroom door when you get to junior high school? The coach, the high school basketball coach. Why? Because you're tall. All right. So is Shaq a big fish in a little pond or a little fish in a big pond? He's a little fish in a big pond. Now Shaq is not little by no means. I mean, he's like 8 feet tall. All right, and weighs 300-400 pounds. I don't know how much he weighs, but usually tall people weigh a lot, okay? Because they got more mass. So whatever. The whole point is he's not a little fish, okay? But as the old saying goes, he's a little fish in a big pond. Why? Because people in the NBA are what? Naturally tall, not naturally tall, but taller, because if you are tall, you are pushed into that direction of being a basketball player. See what I'm saying? So you've got two ponds. They're asking, which one's the bigger fish in the little pond, is what they're asking. Is Shaq the bigger fish in the little pond, or is LBJ the bigger fish in the little pond? And that's what they're asking. Now, how do you ascertain that? Well, you compare them in one system. You convert each of their statistics into a z-score. The further that z-score is away from 0, the more ER it is. That's one of my little sayings. ER, taller, shorter, smarter, bigger, smaller, whatever the ER is. Most of the time. It depends on how the question is worded. All right? That's why you have to pay attention to the question, because there's sometimes which is the better test score. And they'll give you a psychology test and a psychology class average and a economics class average, and the one that's closer to 0 is the better score because it's a score versus a height. I know that sounds crazy, but you just have to, the context of the question, you have to pay attention to. Now, the formula for z-score is right there. If you wasn't able to copy it a while ago, there it is. It doesn't matter. It's the average taken away from the actual value and put over the what? Standard deviation. So you've got to have those three things. If you don't have those three things, you can't convert it to a z-score. So how many numbers are they going to give us in this problem? 6. 3 for Lyndon Johnson and 3 for what? Shaq. So let's look forward. Now, I'm going to go out on a limb here and assume that some people know how to read. And the reason I say that so loosely, okay, bring it down, Vanna. Hit minus until you see my menu. Hit minus. Just keep hitting minus until you see it. There we go. I think that's it. When you read the question, it's going to say the standard deviation is, and it's going to say the mean is. When it gives you that, you're supposed to plug and chug into, where it needs to go. You don't sit there and go, okay, the mean is 75, or let's see, the mean for, let's see, where is it? I'm looking for the mean of the presidents. Okay, presidents, mean of 71.5, and sit there and go, I don't know where to plug it in. Okay, you need to read the formula. Just like I told you in the last class, you need to read the formula, and if you have a question, go back to the formula, because the formula will give you the okay, so it's not going to work. That's because somebody unplugged it. Must be the sound Nazis. Side of orientation, but anyway. X minus X bar over standard deviation. So Z is equal to X minus X bar over standard deviation. So we got to find the z-score for Shaq and the z-score for LBJ. So the z-score for LBJ is going to be his height, which is 75, minus the what? The president's what? Mean, which is 71.5, over the president's standard deviation. All right, somebody crank that out. Take your calculator and crank that out. I'm sorry. 1.67. Thank you. Right here. 1.67. At least you know I'm not copying the notes. Now let's do the z-score for Shaq. He's 100 inches tall, 85 minus 80 over 3.3. And somebody give me that number. 1.52. So who's the big fish in the little pond? LBJ, because he's further away from the zero. So who is relatively taller in their own population? The president is taller. And why is that, do you think? Because there's no what? Height requirement for being president. That's why. I mean, whoever the tallest president is, I don't know. I'd have to look because we've had several since LBJ. I don't know. Somebody have to Google it. Let me know who the tallest president is now. We know who the biggest president is. Who's the biggest president? He was like 500 pounds. I think he was 315, wasn't he? Somebody look up the tallest president. You'd be surprised, but W was very tall. Couldn't tell it on TV, but he was pretty tall. I don't know who the tallest is. Somebody Googling?
It says the two tallest were Abe Lincoln and LBJ, both at 6'4", and the shortest was James Madison at 5'4".
What was W? I just remember him talking about W on TV one day, saying he was pretty tall. That's why.
6 feet even.
No, he's not tall.
That's about average for a guy.
No, but some people, I guess, on some journalists that were covering him, I guess, thought he was tall. Maybe they were short. I'm sorry, vertically challenged. All right, so that's why you use z-scores. Z-scores. You compare apples to oranges now. Now let's talk about quartiles, because that's what you're going to be tested on. I mean, you're going to be tested on z-scores. You're going to have 2 or 3 questions on the test about z-scores. But you know, I'm not going to sit here and tell you this is difficult. It's really not that difficult. No sneezing in class. All right. Let's go to the next page. There we go. Percentiles. I want y'all to go back to the empirical rule. Go back and look at the empirical rule. What page was that on? 103? All right. What is a percentile? Well, I'm going to go and get on a handy-dandy board up here, and I'm going to show you what percentiles are in respect to the empirical rule. I think we can pretty much say that this is the screwed up room. This is the only room where I have trouble with the technology. And we all know it's a conspiracy of whose fault it is. So, alright, the empirical rule basically says this. You gotta help me with this one because I forget this one. What's this one right here? 103. Just round, I don't need a decimal. No, turn back. I had it. Right there. Right side 34. What do you 17.5, good enough. Or 18, whatever you want to put. Which way do we read? We read left to right, don't we? Unless you're from the Middle East, Macedonia. So we read left to right. So, remember your gas tank? You know, gas tank in your car? Dang old. Let's see. I think it looks something like that. Everybody with me? Dang old. Look familiar? Except for that slanted line on the bottom, it should look like that. Alright, so where am I at here? Empty, Hubert. Yeah, that's, correlation right here. Y'all can speak, can't you? Empty. And then right here, we're about a what? Quarter tank. What about here? About a half tank. And full over here. Alright? So your percentiles comes basically from the empirical rule and where you are in relation to center. Of course, center is the most important thing in statistics. So we could say this is the 50th what? Percentile. I'm sorry about the orientation. I can't calibrate it because for some reason it doesn't want to calibrate it. So you're just going to have to, I'm trying to do the best I can without having to start it over. Now, you could also call the 50th percentile the what? Well, which quartile is it? If this is the first quartile, what's this one? Second quartile. Okay, you need to get used to, now it's not exactly the 50th percentile, but I'm trying to get you to relate how to read percentiles. I don't want you reading 28th percentile and coming from the right this way, because we don't read from right to left. Alright? So this is the 25th what? Percentile. And the what? First quartile. Good. Of course, this is your, down here is your mean. And this is your 75th percentile. And your third what? And then your max is over here. Your minimum number and your maximum number. Alright, now, when we talk about percentiles and quartiles now, you know what it's in relation to. It's in relation to these three guys right here. Now I want to use, okay, I want to say it again loosely. I'm not saying that these three marks right here are exactly at the 25th, 50th, and 75th percentile. They're not. This one is the only one that's at the mark. But what I'm saying is, when you say the 23rd percentile, I want you to say to yourself, well, 23rd percentile would be probably right in here somewhere. That's what I want you to be able to do. Okay? Because when we get to z-scores in chapter 6, you're going to be able, I want you to be able to plot the line where you think it is. And in order to do that, you've got to know where the percentiles are. Okay? Now, the formula for percentile of a value is right here. Finding percentile of a value. In other words, you're given a bunch of numbers. Blow it up a little bit, Dana, please. You're given a bunch. That's good right there. Bring it down a little bit, or minus it. There you go. All right. You're given a bunch of numbers, and they ask you, what is 24? 24 is the what percentile? Or they ask you what, in this case, they say 23. What is 23? And they ask you what percentile that is. Well, you got to count. Count where the first 23 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? 11. So how many values are less than 23? 10. So 10 goes right here. Like, go back down, or minus it all the way down, please. Thank you. So that number is 10. Divided by, how many values are there? 40. Multiplied by 100. Please do not use a calculator for this, because you're hanging a sign around your neck that says I don't know how to do math. Why? Because what's 100 divided by 4? So what is that? What is the 23? It's at the what? 25%. Okay? Because what happens to the zeros? They cancel. And this is 100 over 1. 100 times 1 is 100 over 4 is equal to 25. So 23 is at the 25th percentile. Now, Hubert, there's 2 or 3 23s. You don't worry about it. You come to the first what? The first 23, and then you count the number before. Now, there is a test question. I usually give y'all a test question on that just so you'll know how to find the percentile of a number. And that's how you do it. Not rocket science. What I really want to get to is Boxplot, because Boxplot is what a lot of people get kind of confused on. Okay? All right. The other thing that you're going to be asked about, that's simple and not very difficult, is finding the percentile. Will you please stop? All right. Sort the data. First thing you do is sort the data. And then write down this formula. Blow it up, Dana, please, if you need to. L is equal to Kn over 100. I write Kn over 100. L is equal to Kn over 100. Hubert, I thought you just gave us a formula. Yeah. That's when you're given a bunch of numbers. You're given a number, and you're asked what percentile it is. What's this? This one tells you which number is the 50th percentile, or which number is the 30th percentile, or which one is the 33rd percentile, and you got to go in and find the number. So the first one, they give you a number and you find the what? Percentile. Here they give you a percentile and you find the what? The number. So you might want to write that down. In the first formula, they give you the number and you find the percentile. Give the number, find the percentile. In this formula, you're given the what? Percentile, and you find the what? The number. Okay, be magnified, please. And they give us a, well, it must be on the bottom of the previous page. Okay, they give us a table and they say that they want to know the 18th percentile of the previous the 18th percentile. Where is the 18th percentile? Alright, the 18th percentile. Where is the 18th percentile? In other words, where is the 18th percentile? It's right before the 20th percentile. Where is it? Well, 18 is going to be your K. So you would take your 18. Somehow I've turned this thing through. What it do when this thing is not right. You're going to take the 18 and multiply it by n. Now what have I always told you n is? What is n? How many numbers are in the group, right? So in this case, n is what? 40. And divide by 100. Do you need a calculator? Not necessarily. Because what happens to these two zeros right here? And that leaves you with 4 over 10. And what can I do with that 4 over 10? That could be what? 2 over what? 5. And now you got 18 times 2 is what? 36, right? 36 divided by 5. Or you can say 72 divided by 10 is 7.2. What's the answer? Huh? 7.2. You do not need a calculator for that problem. If you have to use a calculator for that problem, you need to work on it. Don't raise your hand and say, I'm talking about you. I hadn't looked and seen anybody use a calculator. You do not need a calculator for this. 7.2. Well, what does the flow chart say about decimals? Dang, let's go read it. It says if you get a decimal, I don't care what kind of decimal it is. Today is work with a screwed up computer day. You all know that? You know, most teachers would give up and just cut class short and make y'all leave. But I'm determined. I'm not going to do that to y'all. You know why? Because somebody will complain to my boss and I'll let y'all go with it. You don't believe me? I'll bet you a biscuit on it. What happens if L is a whole number? When you count to that number. What happens if L is not a whole number? Write that down. You round up to the what? Next number and you count to that number. I don't care if it's 7.01. Does it say anything about 7.5 or 0.5? It says if it's not a whole number. What's not a whole number? 7.01, 7.99, 7.5, 7.3. It doesn't matter. If you do the calculation and you come up with a decimal, I don't care what the decimal is, then you have to bump it up to not 7 but 8, and you count to that number. So let's go back to the table. Down. Let's go back to the table. Kind of help with the table on the side. And count how many spaces? 1, 2, 3, 4, 5, 6, 7, 8. So 22 is your 18th percentile. Or whatever one we're looking for. And that's how you do the percentile to the number. Again, is it important? Well, you might have one question on the test about the percentiles versus 4 or 5 about the box plot. So let's get to box plot. Why do people miss the box plot? Do they miss it because they don't know how to draw the quartiles? No. Do they miss it because they just don't know how to draw? No. They miss it because they don't know how to orient the box plot. That's why they miss it. And I'll show you what I'm talking about. Let me find an example of the box plot. Let me just go to the homework. Y'all hadn't done it anyway, so I'll just go to the homework and pull it up. Now there's 2 or 3 different ways to find the percentiles, and I want you to write that down when I get to it here in just a second. Because, okay, here's one. All right, we're just gonna. They're gonna do. I don't want to do 2. That's not a test question. I don't do 2 on the test. Trying to find a question that is going to be on the test, not one that I'm not going to put on the test. We'll have to do it with this one. Are both of those the same? Okay, we'll find the box plot here. The following are speeds of cars measured with a radar gun. Determine the 5-number summary and box plot for the data given below. First of all, I want you to put the data in order. It's already in order. But I want you to find the 50th percentile, the 25th percentile, the 50th percentile, and the 75th percentile. So K is going to be 25, K is going to be 50, and K is going to be what? 75. What's the N? Does it say how many is given, or you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 is N. So you've got 3 formulas to calculate that quick. Let me help y'all out because some of y'all got the deer in the headlight look. Or meditating on. This, since y'all got it blown up. Just don't make fun of my mouse writing, because mouse writing is very hard. The 25th percentile is going to be equal to 25 times what? What do we say, 15? Do you need a calculator on this one? No. Over what? Dang old 1/4. Dang old 15 divided by 4. 4 will go into 16 4 times, so I bet it's 3.9. What is it?
327.
Okay, 3.8. I was off by 1. So 3.8 tells us that we got to count it up to what? 4. So 1, 2, 3, 4. So 71 is our 25th percentile. Okay, go ahead and do the 50th and the 75th percentile. Or meditate. 50th and 75th. Pay attention to school. Take the roll so I can keep y'all to the last minute. Everybody here? Bailey. Bolt. Miss Clayton is here. Miss Cowart. Let's see here. Miss Dutchke is here. Escobar. What origin is that? Ah, Escobar. Far. Freeman. Hammett. Harris. No Harris. Harvey. Hayes. Johnson. Mullins. Mullins. Oops. Murray is here. Newton. Hoare. Perdesi. 1, 2, 3. Robinson triplets are here. Miss Scarborough is here. Schuler. Simpkins. Dennis. Dennis is a whole lot better, isn't it? Smallwood. Y'all keep switching seats on me. It messes me up. Vaughns are here. I thought I saw it. Yeah. Vaughns are here. Williams and Wood. Okay, got the bureaucrats happy. Now we can keep on going. I don't even know where I'm at now. Let's see. Okay. So, there's the 25th percentile. The 50th percentile is going to be 1/2 of 15, which is what? 7.5, Hubert, which is 8. So, dang old, there's 4, 5, 6, 7, 8. And then the 75th percentile would be what? 11.25, which is 11.3, which is 12. Dang old, 4 times 3, dang old. That's 8, 9, 10, 11, 12. There you go. Now, what the heck does that mean? Well, just hold on a minute. We're getting there. Those are your 3 percentiles. Now, we need to focus on the mid-range. We've got to find the mid-range. Now, there's another way you can find, before I do the mid-range, there's another way you can find the percentiles. And this is how you do it. Copy. And I show this for 2 reasons. 1, so you'll know how to find them another way. And 2, is you know what they actually are. And you see it better when you do it by hand. Alright, everybody agree that's the numbers? Yes, Hubert. No, Hubert. Thank you, class, for the interaction. Alright. Find the median. Well, we said how many were in the group? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is odd or even? So you go back and count 7, and the 8th one is the 50th percentile. 1, 2, 3, 4, 5, 6, 7, 8. So that should be your median. I'm sorry, the 50th percentile is the median, so, or mean. But we're not going to worry about that right now. Anyway, there's that. Now, let me ask you a question. How many numbers are above that 74? 1, 2, 3, 4, 5, 6, 7. Odd or even? There's the other percentile. And then how many are down here? 1, 2, 3, 4, 5, 6, 7. And there's the other percentile. So do you have to calculate? No, you just have to count and find the middle. Once you find the middle, then go above it and find the middle, and then find the middle. So you actually see what the 25th and the 50th and the 75th percentile is. You're counting. What if it's even? Well, let's add one number to it. Well, I better not do that. There we go. Control C, Control V, and I'm going to add 81 here, or another 80. Okay? So now we got 16. So you got to find your mean, which is going to be, well, 16. Half of 16 is what? 8. So we're going to go find the 7th number. So 1, 2, 3, 4, 5, 6, 7. And we're going to take what? Those next 2 numbers right there? 1, 2, 3, 4, 5, 6, 7. Yeah. And what are we going to do with these 2 numbers? So, damn, 1, 2, 3, 4, 5, 6, 7. Now I'm just going to pull that out to the side here, and I'm going to say equals parentheses this guy plus this guy divided by what? Alright, now where is that 75? It's actually where? Right here. So how many numbers do you have above that little cross right there? Well, 1, 2, 3, 4, 5, 6, 7, 8. What do we got to do? We got to do it again. 1, 2, 3. We got to do these 2. Parentheses, this guy plus this guy divided by 2. And then what we got to do on the bottom? Same thing. 1, 2, 3, and these 2. Equals parentheses this guy plus this guy divided by 2. And there is your 25th, 50th, and 75th percentile if it's even. Okay? And the only reason I show this is to show you what you're actually finding. And sometimes it helps you to know what you're calculating when you see what you're calculating, instead of just calculating something and not having any idea what you're calculating. Y'all have never done that, have you? Or never had to do that, have you? It's called regurgitation. As soon as the test is over, what do? You forget it. That's not learning. That's recitation. All right. So now you see what you're getting. Now what do you do with that? Well, now we focus on the mid-range. Mid-range. What is that? That's your highest plus your lowest divided by what? 2. Highest plus lowest. Well, that's your max and your min. So this guy right here and this guy right here is very important. So draw a number line. So we're just gonna go away from our percentiles for a second. Push that to the side, and now we're going to go to the number line. So draw a number line, and that number line is going to be between 70 and 80. Why is that? Because 70 is the what? Lowest, and 80 is the what? Highest. And that's what's always going to be the end of your number line for your box plot. So if I could ever, there's your 70, and it just disappeared. There we go. You ever have one of those days that just nothing works right? Okay, so how do I find the middle? Well, the middle is called the mid-range. Why don't you find the mean? You've been telling us to find the mean. Why are we going to switch to the mid-range? Because the mid-range is not weighted. What is the mid-range? The mid-range is the middle of two numbers. That's it. Is the mid-range influenced by anything? No. The mid-range is just the middle of 70 and 80. So if you want to say it's more of a measuring stick than the mean is. Can the mean be affected by the numbers? Yes. Can the mid-range? No. The mid-range falls what? Where it falls. There's nothing, you can't pull it this way, you can't pull it this way. So the way you use the mid-range is on a scale. You use it for a scale for your number line. And you keep taking the mid-range of the mid-range of the mid-range of the mid-range until you get enough hash marks on your number line as you need. So what's 70 divided by 80? What's 70 plus 80? 150. And what's half of 150? 75. So 75 goes in the middle. All right, find another mid-range. Y'all have to excuse me. This thing is just not working right today. Put it right here. I'm going to put this one right here. And put this one right here. Alright, find your other mid-ranges. Well, we have two numbers here. What are you going to find? Mid-range. You got two numbers here. What are you going to find? Mid-range. And you keep going until you get enough hash marks that you need. Most people do 5 on one side and 5 on the other. Or 4 on one side, 4 on the other. That way your number line is graduated to where you can put a box plot. And I guarantee you, some of you in here that's had 120 have no earthly idea what I'm talking about. Well, you haven't been taught. You've been taught how to regurgitate, but you haven't been taught how to graduate the number line so you can put your box plot where it's supposed to be. Alright, so here we go. Let me put my vertical lines on here because I don't like it the way it looks. And I'm going to put one right here. And then I'm going to put another one right here and another one right here. And then one right here, and another one right here, and another one right here. Okay, so here we go. 70 plus 75 is 145. Half of 145 is what? 72.5? Y'all tell me. So 72.5 goes in the middle right there. And 75 to 80 is 155. Half of 155 is what? Thank you. Now once you get it down to a certain point, you can just about guesstimate what the next one is. Alright, what's between 78 and 80? Thank you. So 79. And somebody say, well, Hubert, you didn't calculate it. Well, does it matter at this point? Why doesn't it matter that I'm calculating? Because what? Can y'all talk or what? All I hear is mumbling. That's y'all's way of answering but not getting the wrong answer because I can't hear you. Why am I not calculating between 78 and 80? Why am I not calculating? Why am I just sticking a 79 there? I didn't calculate it. Because what's the only numbers between 78 and 80? 79. There's no reason to calculate it. What's between 75 and 78? 77, 76, somewhere in there. But I'd probably put a 76 right here. I don't know what the answer comes out to be, but I'm going to put a 76 right there. Okay. What about 73 and 75? What do you think I'm going to put right here? 74. Y'all get the gist of it? Yes, Hubert. Okay, class. Glad y'all are interactive. It always makes the class less awkward and faster. 70 and 73. What's between 70 and 73? 71.5 or 72? You can put 71 if you want to. Well, Hubert, I don't understand why you're just going all over the place now. Well, what are you using these numbers for? To plot a box. It doesn't have to be precise. You just have to have some idea of where the numbers are. Now, let's go back and pull up our handy-dandy percentiles. Is that the right percentiles? Okay, we had them on the... I thought I calculated them. I didn't calculate them. I had them up here. All right, tell me what the first percentile is, or the first quartile is. What is it? That's what I heard. 72.5 or 70 what? 73. So 72.5, I'm going to put the box, the left side of the box right there. All right, somebody give me the third quartile. What was the third quartile? 77.5. And I take my handy dandy black marker and draw the sides of the box plot. Don't laugh at my mouse writing. Make you come up here and write notes. And then what's the 50th percentile? I'm sorry, what? And there's how you draw a box plot. How difficult is that? It's not difficult at all. But see, what happens is people try to, they don't even know how to do the number line. They don't even do it. And they can't figure out where the box is supposed to go. So they just draw it on a line and they don't know how, that's how you draw it. Now, what is this supposed to depict? sorry. Let me try that again. I ran out of mouse pad. What is it supposed to predict? The standard, the distribution, the normal distribution. This is supposed to fall where? In the middle. And then this is supposed to fall right about where it breaks and starts leveling out. And this is supposed to fall where it breaks and level out. Will it always look like this? No. What if you have something like this? What if you have this? Skewed left or skewed right? Skewed right, because all your information is over here. What about over here? Skewed left because all your data is over here. So you got to know what it means after you draw it. So let's look at the problem that we were doing. Okay, y'all got to go. I'm sorry.
Question.
Yeah.
Those three numbers that you plotted,
Mm-hmm.
the quartiles, you got those from the percentiles that we did, right?
Yeah.
Because I got like for the
25th percentile is first.
71. So
Okay.
why didn't you-
Why'd you tell me wrong, man?
Okay, I just wanted to
They're
know.
off just a little bit. They're just off a little bit. That's fine. I mean, as long as you listen. Are you going to get this blue line exactly on this 72.5 or 71.5? No. You're just looking. That's what I was fixing to show you. On the problem, they're going to ask you for the percentiles, and then they're going to ask you to draw a box plot and pick the box plot. And when you pick the box plot, you're just picking the best out of 3 or 4 answers. They're going to have A, B, C, or D, and you just pick the best one. So you're not going to actually see which one is it. Well, it looks like it's that one. Why? This one is skewed what? Left. This one is skewed right, so it's not these two. This one doesn't even look like yours. So the answer is probably going to be that one. See? You're not going to have to draw it, but you're going to have to pick it out.
So the 5-number summary, you're putting in the percentiles and then the median.
This is the minimum. That's your lowest value. This is your maximum. And then here's your first quartile or 25th percentile, second quartile or your 50th percentile, third quartile or your 75th percentile. Y'all have a good day. Glad y'all got to see me today. Y'all settle down. Y'all are too loud. And there's a thing called coffee and Mountain Dew. Drink it before you come to class. Down at the bottom it says duplicate problem, and you can redo it.
And
Down
then
at
you'll
the
count
bottom.
that.
Yeah, right here. See? Similar exercise. So if you get it wrong, get that, and it'll regenerate it, and then if you get that one right, it'll take out your X.
Huh, I didn't know that.
Yep.
Thank you.
All right.